Convolution. Next we start convolution. Convolution is an alternative of partial fraction. So when we are having the convolution, which is very important topic in Laplace transform, so there are a couple of properties of convolution. So one we are having some partial fraction. Sometimes it is difficult. Sometimes when we are going to partial fraction it, we'll getting the same function back. So we cannot take the Laplace inverse. So convolution is the best way. It's an alternative of partial fraction. Number one. And number two, it is used to solve integral equation. Integral or integro differential equation. So it's the best idea is it solve some integral equation and integral differential. Integral equation mean an equation is said to be integral if the unknown function is under the integral sign. I mean integral mean there must be a sign of integral in it, but the unknown function is under the integral sign. Integral sign you are writing and then you are writing unknown function there. So this equation is known as integral equation. And if you are looking for the integral differential equation, it means there is derivative there. There is integral sign there. And the unknown function is integral under the integral sign. Then you are taking a convolution and then you are taking the Laplace to find the solution of the integral and integral differential equation. Properties. So there are a couple of properties of convolution. Convolution is commutative. So convolution means this star. This steric is representing the convolution, and it is associative. G convol V is equal to F convol G convol V. And F convol G1 plus G2, it is distributive over addition. So F convol G1 plus F convol G2. So one of the property can be, it is commutative, it is associative, it is distributive, and then F convol 0 is 0. Then F convol 1 is not equal to F in general. Look, this is very important because this is not the ordinary multiplication. That's why if you are taking the convolution F convol 1, it is not equal to F. So we'll prove in a minute. So since it is an alternative of partial fraction, let me have an example. Using convolution theorem to find the inverse Laplace transform. So we are using the convolution theorem to find the inverse Laplace transform. Let me have h of s is 1 over s plus 2 s minus 4. Let me have. So if I say find the inverse Laplace transform this function, the only possibility left is the partial fraction. If you are a partial fraction, you are separating and then taking the Laplace inverse to get the answer part. This time I am using convolution. Let me 1 over s plus 2 there, s minus 4 there. Let g of s, f of s, First of all, f of s is 1 over s plus 2. Let g of s is equal to s minus 4. You name one function as f of s, the other is as g of s, and you name it according to your choice. You can do it ps and qs, whatever it is. Since they are function in s, so you are writing the capital letter. Whenever in Laplace transform, the capital letters are written somewhere, and it is going to be their function of s. Now once you name, you can find their Laplace inverse, which is e minus 2t. Once you name, you can find the Laplace inverse, which is 4t. This is going to be. So you can find the Laplace inverse by taking the Laplace inverse of the function. It is all the time possible to find the Laplace inverse. All the time. Always. It is always possible. Now, h of t, which is Laplace inverse h of s. H of s is this. If you are taking Laplace inverse, this is h of t, which is the convolution, which is defined of t. Look at that. Laplace inverse of the function is written in terms of convolution, which is 0 to t f of tau gt minus tau d tau. This is the convolution defined. We'll do one more so that you'll be comfortable with it. Once you name fs, gs, then you find ft, gt. Once you find ft, gt, can you find f of tau? Yes, you can find. T is replaced by tau. F of tau is minus 2 tau, and g of t minus tau is t minus tau d tau. Look at that. You have f of t there. T is replaced by tau everywhere. F of tau and g of t minus tau. Everywhere t is replaced by t minus tau. You can either t minus tau, either tau. So it becomes e for t 0 to t e minus 6 tau d tau. Tau is the variable of integration. It means e for t is constant with respect to tau. That is taken out of the integral sign. So e minus 4 tau, e minus 2 tau is e minus 6 tau. Let me integrate. E for t over minus 6 tau 0 to t. Look at that. I am integrating, the minus 6 is in the denominator. This is minus 1 over 6 is 4t. Let me replace tau by t, e minus 6t. Then tau by 0, e0 is 1. E0 is 1. It means, this is the answer, but let me have something more specified. Minus 1 by 6 is multiplied with minus 1. This is 1 by 6, e 4t. Then minus 1 by 6, e minus 2t. Look at that. I multiply minus 1 by 6, e 4t in the parentheses. So I'll get this. And this is 1 over 6, e 4t. So this is, I am using convolution to find the result. So this is the convolution. One of the result. Let me have some more questions. So which is s square plus omega square. Let me have this. I am using the convolution. I am using the convolution to find this, and I am writing 1 over s, and let me have omega there and omega here, s square plus omega square. Let me write this. Let me name this as f of s. F of s is 1 over s, and g of s is equal to 1 over omega over s square plus omega square. This I have written. And if I am naming, I can find their Laplace inverse, which is 1. F of t is 1 because Laplace transform 1 is 1 over s and its Laplace inverse is 1. Laplace inverse g of t is equal to 1 over omega sine omega t. This is the Laplace inverse is sine omega t. Now you are finding the Laplace inverse using convolution. So it is good since convolution is commutative. So the best idea is if I am writing f of t minus tau g of tau d tau, it is good because your function is constant. And if you are replacing t minus tau, it is 1. So the best is this. It is commutative, you can do it, it is 1. Then sine 1 over omega is there. 1 over omega is there. And sine omega tau d tau g of tau. So g of tau means t is replaced by tau, not t minus tau. We have that t minus tau. So we are integrating that. Minus 1 over omega square cos omega tau. The limit is 0 to